Hey guys, welcome to a quick video on the new powered guidance mod for KSA. Some of you might have seen it in the Discord. I've been working on it for a while now, but I've been kind of trying to focus on making it a little bit more user-friendly, and today I'm just going to basically talk through some of the features. So similar kind of interface to what people might be familiar with from Mecjo. We've got target orbit, we've got some send settings, we've got some more parameters we can tweak. We can basically show the desired orbit that we've selected in the overview here using this little toggle down here. We can see if we change the inclination, oh, I lost it. There we go. Change the inclination, it will move to a different position. We can change the apogee, get some crazy elliptical orbits like this. We can change the longitude of the ascending node to give our precise orbit if we kind of launch for a target. We can set a target here. So in this case, just like Mecjo, we'll warp all the way around the planet and basically until we're under the track and then launch. With an offset as well below, so we can decide if do we want to be a chaser or do we want to let them catch up to us. For now, I'll just go for none. I'll keep the orbital parameters there. Reset the land to our position so we've got launch that makes sense, and we will go. So in the ascent settings down here, we can change the turn rate and the turn start altitude. For this vehicle, it's about 0.5. This all updates in real time as well. And G limit. So this is a pretty powerful first stage. So I'm just going to put the G limit on and go to about 2G. And that'll give us something a little bit more reasonable. Throttle down that center engine. Obviously can't do anything about the SRBs. And it's pretty good on the time warp, as is pretty much everything in this game. Very performant, especially compared to KSP. So there go the boosters. We're now on the UPFG guidance, the closing loop guidance. We've got a little display here which tells us our distance to go, time to go, and velocity to go. So you can actually see the distance to go decreases quite a lot faster than the velocity to go, which is because we get a lot more of our velocity in the later parts of the launch as the vehicle burns off fuel and its acceleration increases. Yeah, there we go. If you can see, if we reduce the G limit, it basically changes our distance to go and changes our vehicle position in real time. This is a pretty low thrust first stage, so it's giving us quite a lofty trajectory here. You can see on the map our trajectory. So I'll walk this forwards. You can see we're that was quick. Stage is gone. Onto our final stage here, and 180 seconds to go. Orbit's coming in nicely. $60 seconds to go. Once we reach 10 seconds, we'll hit a terminal freeze, where basically we just keep the same orientation so we don't end up chasing our tail on the guidance. And there we are. And that is cut off. Pretty good orbit, about 3 kilometers out from what we picked, so it's pretty good performance. So we can basically then just do this in reverse to land, right? So by opening scenario here, got a scenario here which is lander in orbit around the moon called Hopper, and going to the descent tab, we can see we can set a descent target. So we can at the moment it's at the Apollo 11 point. We can click, we can retarget as we like. We can get some pretty big deviations if we want. It can handle all of that. And then we can select what solver we want for our final guidance, which I'll get into that. I'll leave it on G-fold for now. And execute. So we can either warp to the descent point, or the beauty of this compared to KSP is we can just keep warping. We can just warp straight over the orbit burn point, and in full time warp it will start burning and start bringing us down to the target. Let's say we want to target Apollo 11, so we can just hit retarget Apollo 11 and the vehicle will adjust its orientation to land at a new target. So it's pretty cool. So there's 2 landing solvers, which will transition into T-40 seconds. That is customizable in the approach parameters here, as is basically everything is configurable. I've tried to choose defaults that kind of seem sensible, but I think if people want to use this, your mileage may vary and you might have to make some of your own tweaks to the exact parameters to dial it in for your vehicle. So the landing solvers, we've got gfold and we've got sixdoff. Gfold, I think sixdoff may be renamed, but gfold is effectively an algorithm that was developed by some of the guys who went on to found the guidance team at SpaceX, which is pretty clever bit of math. I'm happy to go into it more if people are interested, but I won't bore you with it, how it works here. But basically, it's a fuel optimal landing, so it should take us to our landing point with the mathematically optimal least amount of fuel burn. So there's our site. We're coming in. And then at 40 seconds to go, we transition into gfold. So we've got a live readout of the blue is our planned trajectory, the yellow is our thrust direction, and the pink is our trajectory so far. So you can see we're following this pretty well so far. We can also choose to show the overlay if we want, which basically gives us our real time trajectory overlaid on the world. I'm not sure I'm liking what I see here, but we'll see. Yeah, we're going to go a little bit over here. This may be a bit of a bad demo, actually. It's handling it okay. And below a certain height, we transition into a hover autopilot, which is this mode here. So just to quickly interrupt it, basically, this is for the last bit of the descent down to null any kind of final velocity and gives us kind of an Apollo-style landing. So it's actually kind of just fun to play around with. So you can basically choose using the numpad or the buttons here. I could go north and basically set a desired velocity. And this isn't optimal, this is just control loops, old school PID stuff. The vertical speed is defined as a function of our height. So the vertical bias here isn't an absolute descent rate, it's more an adjustment to a vertical profile that's basically designed to touch us down nice and gently. Again, this has to be tuned per vehicle. If you use the six-dot mode, which I'll get into, you shouldn't actually need really this mode for anything but the last couple of feet or not at all. But yes, it's coming down. We reset to 0 and touchdown. Right, I'm back. PC just crashed on me for the last one, so sorry about that. Nothing to do with the mod, I promise. But now I want to demonstrate the sixth-off mode. So the limitation with gfold is it assumes instant thrust pointing and it assumes a point mass, but a real vehicle obviously has inertia. It takes time to point. So the way sixth off uses a different method called successive convexification, which basically we linearize a reference trajectory, and that allows us to basically handle non-linearities in our problem formulation. So if we have rotations, if we have air resistance, that sort of thing, we can basically solve those all in real time pretty accurately. Maybe not to a true global optimum, but there's no point being globally optimal if you end up crashing, right? So it's about finding a balance, and it gives pretty good and fairly optimal results. So select sixth off in the toggle down here, and at the handover, at T minus 40 seconds, we should switch over, and we'll see how this one does. So there's 40 seconds there, and we are now in the sixth off mode. Same as before, we can show our plan overlay here, and this you can see actually brings us down quite a lot more gently. Before we get too close, I'm going to show some of the redesignation abilities. So if I hit retarget and then select another spot, we should be able to land at this new position. You can see the vehicle pitching up. So this is like when Neil Armstrong was coming in, he was dodging the boulders. We can kind of do the same thing with our redesignations. And we basically then calculate a new fuel optimal trajectory to the new point. Coming in overhead, killing our horizontal velocity. So the solver this time is aware that our vehicle has inertia, and then we're transitioning into our final hover for our final landing. Could have probably taken it a little bit lower on that one. In theory, the sixth off can go all the way to the ground. there are a few little bugs still to iron out with the 6 DOF. Mainly, it's just getting it running in real time has been a bit of a challenge, and sort of optimization is ongoing on trying to get it just as performant as possible. So one of the cool things about the 6 DOF model is we can deal with some pretty crazy situations like the Starship belly flop. Huge amounts of inertia, limited control authority, highly nonlinear coupling of all our controls. So target our pad here. We'll set a 50-meter stop altitude, and we'll see how we do. So let's go. Okay, so it's a pretty strong initial flip. I'm getting some warnings here. This is something I'm working on, just kind of fine-tuning that solver, dialing it in. But you can see it's managed to flip, and it's bringing us down pretty well towards our landing pad here. Even with the air resistance, even with the non-linearities, it's compensating pretty well. And it's brought us down nicely towards our terminal hovering position, which is exactly what I wanted. So that's pretty cool. I will say it doesn't always work this well. Some runs do fail. Like I say, I am working on optimizing it all. And gone. Bang. Right. Let's. One last thing I want to show you is we can basically control multiple vehicles from this. So this scenario here, we've got 2 boosters, both flying. Kind of imagine if like Falcon 9 landing or something like that. Sorry, Falcon Heavy landing rather. So I'll just go and set these up. So we have 6 DOF retarget and target them both to the landing pad. Let's set them both to 50 meters. We should get a cool hover going on. And make sure it's 6 DOF, 50 meters, and retarget. And let's see how we do. So execute and execute. So now we've got both vehicles in real time computing their trajectory to land back on the landing pad. He's been a bit more aggressive than the other one. I know he's catching up. It's like a race between them, but we should see them come down both to a nice hover right next to each other. Ah, look at that. Brilliant. So you can, as you can probably imagine, oh, he's off now, but we'll focus on this. As you can probably imagine, the possibilities is fairly endless. Where you can have an upstage carry on with the ascent while the booster does his boost backburn, which is something I'm working on, comes back in, or you can have Falcon 9, Falcon Heavy rather, style landings, or you can basically do anything you want. Let's see where this guy's going. Okay, so he's off, so some work still to be done. But yeah, if people are interested in this, if people watch this, I would be more than happy to talk through how some of the stuff works in some future videos. Equally, if it's too nerdy for people and they don't care, that's also fine. I'd hope that some people get some fun and some use out of this, out of the mod. So yeah, thanks.